Now we're going to finally look at fuel cells. Fuel cells use the energy from the reaction of a fuel with oxygen, so from combustion, to create a voltage. The fuel and the oxygen flow into the fuel cell and the products flow out, and the electrolyte remains in the cell and won't need to be replaced because it will be used at one electrode and reproduced at the other. So it'll be used at one electrode, produced at another. They can operate continuously as long as you keep putting fuel and oxygen in. They do not need to be recharged. They don't lose their voltage. As long as you keep putting fuel in, then you will just see a continuous voltage over time. Here's an example of the alkaline. So that means in hydroxide ions, hydrogen-oxygen fuel cell. So that's hydrogen and oxygen reacting to make water. We've been given the two equations. Again, it's worth making sure that you can remember these two equations. The more positive one, remember, is on the right-hand side, and the more negative one is on the left-hand side. Remember that the positive one is the one that undergoes reduction, and the negative one is the one that undergoes oxidation. So you can always remember that by remembering no problem. The negative is the oxidation, the positive is the reduction. So the more positive one is going to go this way, and the more negative one is going to go backwards as oxidation. The cell has two electrodes made of porous platinum because there are no metals in this hydrogen-oxygen fuel cell. They're separated by a semi-permeable membrane that is going to allow the ions to flow without and complete the circuit. So that's like our salt bridge. And the electrolyte we use is an alkaline, so like KOH or NaOH. So hydrogen, so hydrogen's here, it enters, so remember it's more negative, and the more negative is the oxidation, and that is the negative electrode. So it enters at the negative electrode, so it's oxidation, no problem. Yeah, so no, negative is oxidation. So the following reaction happens, the one that's negative goes backwards, so hydrogen plus 2 hydroxide goes to 2 waters and 2 electrons. Electrons are released in this reaction. They flow through the circuit, through the external circuit, to the other electrode, the right-hand side, where reduction happens at the positive electrode. And so oxygen gas and 2 waters and 4 electrons react to make 4 hydroxide ions. If we were to try to combine these two equations, remember we'd have to double the top one to make the electrons match. And when we would do that and then cancel out things that cancel out, we'd be left with hydrogen, 2 hydrogens plus oxygen. So we'd cancel out the hydroxides, we'd cancel out some of the waters, make 2 waters. We can see that what we're doing is the combustion of hydrogen. And the EMF is the more positive minus the more negative. That is 1.23 volts. And what we can say about this is that the OH minus does not need to be replaced as it is used at the negative electrode and produced at the positive electrode. What if we were to change the conditions? So instead of doing it in alkali, we do it in acid. The half equations for the reaction have now changed. But if we combine these two half equations, we'd have to times the top one by 2. We would see that we would end up with 2H2 gas plus O2 gas. The 4H pluses would cancel, because remember we're doubling the top one. And we make 2 waters. The 4 electrons would cancel. So we can, if we look at it, we can see that this is the exact same reaction we had a minute ago. And therefore it will be the same EMF, even though I haven't been given them. It must be the same because it's the same overall equation as the alkaline fuel cell. So same EMF. What are our advantages then and disadvantages of using fuel cells? Well, fuel cells are way more efficient. They convert more of the available energy that they have stored into useful energy, into kinetic energy, as opposed to using other types of cells or combustion in a car for fuel. They are so much more efficient. You get much more kinetic energy from the stored potential energy. They don't produce CO2. They only produce water, so they don't contribute to global warming in the same way. Fuel cells produce continuous supply of energy as long as you keep supplying them with fuel, so they do not need to be recharged. It's an advantage. What are the disadvantages? Well, hydrogen must be produced. This can only be done by electrolysis, which uses fossil fuels, and therefore that kind of negates the fact that we're not producing CO2. Hydrogen's highly flammable, and so has to be stored very carefully and transported very carefully. And there is no infrastructure, so there's no hydrogen petrol stations or hydrogen fuel stations. And also, you do have to store the hydrogen as a liquid for use in fuel cells, and liquids, and these liquids, they take up less space. So the same amount, so rather than storing it as a gas, we always store the hydrogen as a liquid because it takes up less space. We get the same amount of moles of hydrogen, but in a smaller volume than if we'd have stored the gas. So we always store it as a liquid because it takes up less space.